Hey everyone, how it goes and welcome back to Computer Science 146. Today, we're going to talk more about queues. In a previous lecture, we went over that a queue is a first in, first out data structure. It's used to process data in order. And you can consider this as waiting in a line. The common queue operations are enqueue that adds a new element to a queue, dequeue that removes the first element from a queue, peeking, which involves observing the first element but not removing it, and also printing all the elements of a queue. In order to further explore this, let's take a look at an example. Let's say that we were going to create the following game. This game is Hot Potato. Now the way this works is we have three different players, as you see up there, and a potato that you see right there. Now in this game, the potato is assigned some kind of secret time, and let's say that time is between 10 and 30. We also keep track of the current time that the potato has been held. Now as mentioned before, the secret time is assigned some value between 10 and 30, and let's say that it was first assigned to 15. As you can see, we also assign the current time to 15 as well. Now what we do is pass the potato to each player in order. So we're going to go ahead and pass this to the first player. Now what each player has to do is say how much time they're going to hold on to this potato. Let's say the first player says 5. We take that value and then we subtract it from the current value. That makes it 10. Then we pass the potato to the next player in order. The next player says 3, which reduces the current value. Then we pass the potato to the next player, let's say they say 4, which reduces the current time down to 3. Then we pass it to the next player that says 2, reducing current time to 1. Now we pass it to the next player, and let's say they said 5. Now the current time is -4. Whenever the current time is 0 or below, we have to eliminate that player. So then this player is taken out of the queue. Then we reset the time to something between 10 and 30, and then pass the potato to the next player, until finally there's only one player remaining. Now that we've described the game, let's see how we can look at this and use a queue in order to accomplish it. First, we're going to name each one of the players A, B, and C. Now we can see that every one of the players is inside of a queue, and there we have the head and the tail of the queue. Now using the exact same example, let's say that the secret time and the current time were both assigned to 15. What we do next is dequeue from the queue of players. This means the first element, which was player A, now becomes the current player. And our queue is updated to look like this, where only players B and C are in the queue. Now again, following the example, let's say that player A said 5, which reduces the current time down to 10. Now as the current time is not 0 or less, that player has not been eliminated. So what we do then is add player A back to the queue, and now player A becomes the tail. We repeat this exact same procedure, so then we dequeue. Now the current player is B, and what's remaining in the queue is players C and A. Now let's assume that the exact same turns happen again. Eventually we end up with this. Player B has entered a time of 5, which now makes the current time -4. -4 is less than or equal to 0, so player B has to be eliminated. The easiest way we can accomplish this is simply by not adding them back into the queue. Then the only players left are players C and A, and this keeps happening until one of them is left. Now that we understand the game and how we can use a queue to do this, let's see the code. As you can see, we already have the project set up and ready to go. Now the convenient thing is we've already written the code for a queue. So why not reuse that code? Simply enough, I'm going to paste the code that we had written for a queue into our source folder. And more specifically, I'm going to use the linked list version of a queue. Some of these data structures that we're going over are already built inside of these programming language libraries. However, we're creating these that way we have the ability to modify them and use them how we see fit. And in fact, we're going to modify certain elements of our queues in order to best suit this game. The first thing I'm going to do is open up the queue interface. Now once again, what an interface does is it defines this type. But furthermore, anything that implements this interface must have the following methods. This is one critical way that we can use polymorphism, that anytime this QI is used, it must implement this, so this thing, QI, can be implemented in many different ways. Now, how we're going to modify this is it's a good idea to keep track of how many elements are in this queue. So simple enough, I feel that this should be a method included in every version of a queue. So to update this interface, I'm going to now include public int size. This also might be a good method for other data structures as well, including linked lists. Now once I've added that, you'll notice that there becomes a syntax error on our linked list queue. And this is because we have yet to write this method. In order to write this method, we're going to have to change some things inside of our linked list queue. The first thing that we're going to do is add a brand new property called private int size. Now, anytime something is enqueued, we have to increase the size. Anytime something is dequeued, we must decrease the size. Scrolling down to enqueue. The first time an element is added to our queue, we must assign size to 1. Now otherwise, if we already have elements in our queue, then what we need to do is increase the size, and I'm going to use size ++. Now similarly, when we dequeue something, we need to reduce the size. So inside a dequeue, I'm going to call size -. Now we're not done quite yet. As you can see, we still have a syntax error on this type. This is because we have not defined the method getSize. So let's scroll down to the bottom and create one. So we're going to enter down and create public int size. And simply enough, we're going to return this .size. And now after we've saved this, the syntax error is gone, and we have written all the methods that were in this queue interface. Now the reason why we need this property is the element of the game where we have one player left. The next thing that we're going to do is create the game itself. And after that, we're going to create the front end in order to run the game. Let's go ahead and create this hot potato game. Creating a brand new class. I'm going to name this hot potato game and just create it like this. Also going to put my name at the top here. Now let's think about a couple of the elements that were described in this game. We need to be able to pick a time between 10 and 30, and we want to do this randomly. I'm going to include a type that's going to allow us to create a random number generator. So we're going to create import java.util.random. That way we can use the type random to generate random values. Now inside of our class, we're going to create a couple of properties. First, we're going to start out with some constant values that's going to be used to create this random time. The first one is going to be public static final int min rand time is equal to 10. We want the randomly picked time to start from the value 10. That's the minimum random time. Now the next property, public static final int max rand time, and this is going to be equal to something a little strange, 21. We'll discuss why this is in a little bit, but for right now, here's what we need to consider. We need to start from this value 10. Now going from 10 to 30, there are 20 values in between. What this acts as is a range. As we know, the random number generator selects values from 0 to this value exclusively. So it will never select 21, it will select one below that, 20. As we'll see in a little bit, this will allow us to select the values from 10 up until 30. Now within this game, we have a data structure, the players. The players are first in, first out. This indicates to me that we can use a queue. We're going to use the interface as the type, QI. Now this is a generic type. So what type are we going to use to represent the players? To keep this simple, we're only going to keep track of their name, which is going to be a string. And we're going to call this players. Now from there, the last property we're going to keep track of is a private int current time. Next, we're going to write a constructor, and we're just going to assume a default constructor. Public hot potato game. And what I'm going to do is create a private method, private void init, that's going to initialize all of the properties from here. Now also, not forgetting this, going back to my default constructor, I'm going to call the method init to initialize everything. Now inside of initialization, what we're going to do is assign the players equals to new. Now remember, interfaces cannot be constructed. You have to construct the class that implements the interface. So what we have is this linked list queue, which is also a generic type, and we're going to say this is of type string, and we're going to construct this type of queue. Now the next thing we need to do is assign this current time by first randomly picking a time and then assigning it to here. Now this action of randomly selecting the time and assigning this current time, as we noticed, happened a couple of times as we were doing the game. This feels like a different action. This feels like a different verb. So what I'm going to do is create a method to select this current time. Outside of init, I'm going to create public void reset time. And what this is going to do is use a random number generator to select the current time. So first, we need to create an instance of a random number generator. So we're going to use the type random, call it R, and construct this new random. And now we've created this random number generator. Now using this, we have to call this dot current time, and we're going to assign this to a random value. Now let's look at this closely. If we were to call R dot next int, this is going to select a random integer. But how? Hovering over top of this, we read the description. First of all, it returns a type int, and it returns the next pseudo-random uniformly distributed int value from this random number generator sequence. The general contract of next int is it will select an int value that's pseudo-randomly generated and return all 2 to the power of 32 possible integer values. Well, that's not what I want. I want it to select a value from 10 to 30. if we read through the documentation, there is an overloaded version of next int, where inside the arguments I can pass this, max rand time. Now, let's notice how the description changes. So reading through this, it selects the value from 0 inclusive, so it includes 0, and the specified value exclusively. Our value is 21, so it does not include 21, which means this selects a value from 0 to 20. But there's still one more issue. We were going to select the values from 10 to 30. Well, all we need to do is randomly select this value and add the min time to it. Now we know this selects a value from 0 to 20. Simply adding 10 to it, now this whole thing selects a value from 10 to 30. Now going back to init, this dot reset time, and that way it initially selects a random time. Now before we even start the game, we need to add a number of players to our queue. This feels like a different action, so I'm going to create a different method. Public void add player string a name. Now, as this is a class type, it's always a good idea to check whether or not it's null. Now, if this was null, this could cause problems later on. Then simple enough, if a name is equal to null, then just return. We don't want this property to be null. However, if that's not true, let's add it to our queue. So players.enqueue a name. And now we have successfully added a new player to our game. Now, every time the potato is passed, we need to get the current player so that they can enter a value. This again feels like a different kind of action. Whenever we encounter actions or verbs, they are methods. So, public string get current player. Now, in order to get the current player, we're going to remove them from the queue. So we're going to return players.dequeue. Now, how we're going to use this later on is the current player is removed from the queue. If they were to give a number where the current time goes below or equal to 0, then they are not added back into the queue. But if the current time is still above 0, then they're simply just added back into the queue. This creates this first in, first out circular fashion. Now we need to indicate if that player has lost. Again, this is a different action, so we're going to create public boolean has lost, and we need to provide a time. Now from the front end, the player is going to provide this time. Now we need to evaluate whether or not we're going to add them back into the queue or have them eliminated. So what we're going to do is update the current time. This dot current time minus equals the given time. Next, we're going to return this dot current time, and if this dot current time is less than or equal to 0, then they have lost. Now we also have to finally determine if the game is over. The game is over if the queue is exactly one element. Public boolean get when. And all we're going to do is return players.size is less than or equal to 1. Now this should be exactly 1, but I always like using an inequality just for convenience sake. Now what we have here are all of the actions in order to create this game. Now we need to provide the users, the players, an interface to play this game. I always like separating the front-end interface from the back-end code. So this is why we're going to go ahead and create another new class called Hot Potato Game FE, front end. And this is going to contain our entry point, the main method. I'm going to go ahead and clean this up a little bit. And also provide my name at the top. Now from here, we know that we need some user input. And we're going to get this from the console, so we're going to import java.util.scanner in order to use the type scanner to gain access to information provided in the console. Now I'm not going to write everything in the main method. I'm going to separate a lot of this functionality out into different methods. This means I'm going to create some properties that also need to be static. Always remember, static methods can call other static methods. Static methods can use static properties. However, static methods cannot call non-static methods, nor can they call non-static properties. So this is why I'm going to create public static scanner keyboard equals new scanner system.in. That way I can universally create this keyboard scanner and use that among all of my methods. Now I'm going to do the same thing for our hot potato game. Public static hot potato game, and I'm just going to call it HPG equals new hot potato game. It wasn't mentioned before, however, we need to consider what values that the players can enter. Of course, these are times in order to hold the potato, but we need to define the range of times that they can enter. I'm going to say, by minimum, they can only hold the potato for 1 time unit. Also, maximally, they can only hold it for 10. These two values do not feel like they're going to change, they're constant. So below that, we're going to create some constant values. Public static final int min time is equal to 1, and public static final int max time is equal to 10. Now we're going to enter the main method. The first thing I want to do is greet the user. This feels like a different action, so I'm just going to create a simple method to do that. Now once again, this method is static, that way we can call it directly from our main method. And all it says is welcome to the hot potato game. Now back into the main method, we're going to call greeting. Now we could have easily just put the system.out.println right here, but it's also a good idea to separate this functionality out into methods. That way, if I needed to modify the greeting, well, it's really easy to find. Now the next thing that we're going to do is create a loop to play this game. And we're going to keep playing this game until the player decides to stop playing. So easy enough, we're going to create a Boolean play game and just assign that to true. And then, while play game, we're just going to keep playing this game over and over and over again until the player decides to stop playing the game. Now before we start playing the game, we're going to call hot potato game and reset the time. Now this was called from our constructor, but as we can play this game multiple times, we want to make sure to reset the game every single time. Now we need to give a number of players who are playing this game. This once again feels like a different action, and so I'm going to separate that out into a different method. Going below here, I'm going to create public static int get number of players. Now this has to return an integer value, so I'm going to create int num and set it equal to 0. I'm also going to go ahead and call return num at the very end. Now in order to play this game, we need to have more than one player. And what we're going to do is keep asking the user to enter a value that is greater than 1 until they do that. Well, I just used the phrase until. That tells me this probably should be a loop, like a while loop. So I'm going to do while num is less than or equal to 1. This means this number is invalid for our game. So while this number is invalid, we're going to prompt the user, enter the number of players must be greater than 1. Then we're going to call num equals keyboard.nextInt. And as we have statically defined this, we can use it from right here inside of this method. Now, every time we call nextInt, nextDouble, nextBoolean, it's usually a good idea to call keyboard.nextLine. That way we don't run into a fairly common logic error where there might be some extra characters left off at the end of this, like the end line character, that might be consumed by the next call of next line. So once again, whenever you use nextInt, nextDouble, or nextBoolean, go ahead and use this right here to fix it up. Now, if they've entered a correct value, this is going to evaluate to false, and then we're going to return the number. From our while loop, we're going to create int num players and call get number of players. Now, once we have the number of players, we need to add them, so the players need to provide their name. This, once again, feels like a different action. This should be a different method. So we're going to create public static void add players int num, the number of players that we're going to add. Now we understand that a for loop is a counting loop, and we could use a for loop in this case. However, I'm going to do something slightly different. I'm going to create the while loop version. Int I is equal to 0. So initialize I to 0. While I is less than this number. We're first going to prompt the user, enter your name, player, I, 0, 1, 2, 3, etc. The next thing that we're going to do is capture their name. So string input is equal to keyboard.nextLine. Now here's the thing. I want the player's name to be valid. So first of all, we don't want this input to be null. And I'm also going to argue that this should not be an empty string. So to accomplish this, I'm going to first check if this input is equal to null. Now, if it's not null, or input.isEmpty, if it's null or it's empty, we don't consider this valid. So we're just going to say that's an invalid input, and then we're going to call continue. If this statement is reached, it immediately jumps back to the top of this while loop and starts it over again. That way that player must enter some valid name. However, if they did enter a valid value, then we're going to call our hot potato game .addPlayer input. And then outside of that else, we're going to do I++. Now we can enter the player's name, which is going to add this to our queue. Scrolling back up. We're now going to add players with the num players that was provided there. Now once we have randomly picked this time and we've added all of our players, we can now begin the game. We're going to create another loop. Boolean game over is equal to false, and while not game over, well, we're going to keep playing the game. Now we're going to get the first player from our queue. String player is equal to hotpotatogame.getCurrentPlayer. And remember, what this does is it dequeues. It removes the first element, which becomes this player. Now we tell that player, enter a time to hold that potato from our minimum to the maximum time here. Then we capture that input, int time equals keyboard.nextInt. And then once again, because this is a next int, I'm just going to call keyboard.nextLine. Now we need to validate this time. Let's just say that they entered an invalid time, like for instance, something that was below 1 or greater than 10. If that's the case, then let's just assume the max time. So we're going to check if the inputted time happened to be less than the min time, or this time was greater than the max time. This would be invalid. So what we're going to do is assume this. Incorrect value, assuming the time is the max time. Then we're going to reassign time equals to the max time. Now we need to check if that player has lost. So if hotpotatogame.hasLost, now passing in this time here, this will become true if that time, in other words, if the current time that's held inside of here is less than or equal to 0. So if this is true, then we say this player has been eliminated, and then we need to call hotpotatogame.resetTime to once again randomly pick a new current time and start over. If the player entered a time and had not lost, so there's still some time left on that potato, then what we need to do is take the player that was dequeued and enqueue them back into the queue. So we can reuse hotpotatogame.addPlayer, player. And this creates the circular fashion. Now once all of that's been said and done, we're going to assign game over equals to hotpotatogame.getWin. So if there is only one player left, it's going to stop this while loop. Now let's assume the game was over. What we're going to do is prompt the users who the winner is by getting the current player. And then we're going to ask them if they want to play again, and if they do, they just have to enter yes. We can then just capture this input and then assign play game, which is our Boolean up here, to whether or not input is not null, and if the input equals ignore case yes, then we'll play it again. But if they don't want to play again, then we'll just say goodbye. Now, let's see this game in action. Running it. We're going to enter a number of players. Let's just say 3. And let's say their names are just A, B, C. Okay. We need to enter a time. Let's say 3. Then we'll say 4. Then we'll say 5. Then we'll say 2. 3, 4, 5. Player A has been eliminated. So then we move on to player B, and we keep going. Let's say 3, 4, 5. Player B has been eliminated, and then the winner is player C. Now let's go ahead and play it again. Number of players, let's do 4 this time, A, B, C, and D. All right, let's just keep entering the value 3 and see what happens. Okay, B's been eliminated. Now we have A, C, and D left. Player A has been eliminated. Now we only have C and D left. Player C has been eliminated, and the winner was player D. Let's go ahead and enter no, and we're done with this game. In this lecture, we've shown an example of how to use a queue, this first in, first out data structure. We created a game of hot potato where players have to name these times in, first out order, and then are either eliminated or added back to the end of the queue to once again add values. With all that being said, I'll see you next time.